Good morning, welcome to the Lionheart Academy. This is Richard Tai. Today we're continuing our trigonometry lessons. This is lesson number 20. We're still talking about functions of any angles. Now, if you remember, back then we started talking about the trigonometry functions of acute angles using right triangle trigonometry. Then we expanded our definition, we expanded our horizon into functions of any angles using a coordinate plane such as this, and then using this we're able to deal with functions of any angles starting from 0 degrees all the way through 360 and beyond, also negative angles as well. But we've been using the degrees primarily. We haven't really talked about radians. We did talk about radians, but we'll come back and address radians just a little bit more. Also, there are other examples and problems that we have not been talking about. But here, today, we're going to talk about functions of 90 degrees plus minus theta, which is pi over 2 plus minus theta. We're going to use our the diagram here to develop to help you understand, to see what's the relationship between the function of 90 degrees plus minus theta and the theta. Okay, so this is a basic approach of our triangle here. We're going to be seeing this a lot throughout this course, throughout trigonometry. The radius is here. This is the theta. This angle is the angle theta. And this is y, this is x. Alright, so what happens when we add 90 degrees to this angle? Okay, let's first of all do 90 degrees of plus theta. Okay, what happens when we add 90 degrees? Well, when we add 90 degrees, we're basically adding a 90 degree, adding a right angle. So as you can see, this angle is 90 degree angle. So totally this will be 90 degrees plus theta. So the new blue angle here, the blue terminal side, will represent 90 degrees plus theta. So from here all the way to this guy, this will be 90 degrees plus theta. Now the radius will not change because r will not change, but let's call r prime. R prime is just the same as r. Alright, but now we actually have two new y measurements and x measurements. Okay, the x measurements and y measurements are totally different than the previous x measurements and the y measurements. So let's call this x prime and let's call this y prime. I'm going to use different colors to stay consistent. So this will be y prime and then that will be x prime. That'll be x prime. Okay, and as you can see, but just by the diagram, that this x, the distance x, when you rotate it here, is the same as your distance y. So this is equal to x, the original x. But x prime is equal to the negative y. So the x and y actually switched. The x, y actually switched. The reason is these two triangles are congruent. Okay, remember this is angle theta, right? And the angle theta is actually here. This is the angle theta. When you rotate like this, these two triangles, they are congruent, but this angle theta has changed position to here. So as you can see, this y prime was the adjacent side x, and this x prime was adjacent side y, was the opposite side y, opposite leg y. Alright, and this is 90 degrees, and because the reason is all three angles here, this is 90 degrees, right? This is theta, and so that is the complementary angle, which is equal to this angle right here. So I'm going to use a different color here. So this angle is the same as this angle, as you can see, because all three of them add up to 180 degrees. So that's the key where you can prove that these two triangles are congruent with r theta, r prime being equal to r. Okay, theta is angle here, theta angle here. They are congruent, and these two angles are congruent. Those two angles are, because these two angles are complementary, they add up to 90 degrees. So this is 90, this plus that, all three of them again add up to 180 degrees, and these two add up to 90. That's why this angle is theta. So this side is the adjacent, the new adjacent side, but it becomes equal to x, and then x prime becomes equal to negative y. Alright, so let's go ahead and take a look at what's going to happen here. So sine of 90 degrees plus theta, okay, will be equal to y prime, which is x, divided by r prime. Okay, r prime is equal to r, so it's x divided by Well, let me go ahead and write it out here. Is y prime over r prime, right? But y prime is the same as x. It's in positive. It's the positive value here, and the r is the same as r. So it's the same as cosine of theta. So when you do sine of 90 degrees of plus theta, you get back to cosine of theta. And let's do cosine. Cosine 90 degree plus theta will be equal to x prime over r prime, but x prime is equal to negative y. Okay, y is negative because it goes in the negative direction, so we have to do negative y over r, so it's negative sine of theta. Okay, what about tangent here? Well, tangent 90 degrees plus theta will be equal to y prime divided by x prime. So in this case, it's negative. It's x over negative y. Okay, of the original triangle here. So it's negative cotangent of theta. And cotangent of 90 degrees plus theta will be equal to x prime over y prime. So x prime is negative y over x, so it will be negative tangent of theta. So you can see the pattern here. Okay, let's go ahead and finish everything, and then we'll talk about the pattern. But pay attention to see what kind of pattern we're having. Okay, for secant, it will be r prime over f prime x prime. So this would be r over divided by negative y equal to negative cosecant theta. Okay, and then cosecant of 90 degrees plus theta will be equal to r prime over y prime, but y prime is equal to x, so that's equal to secant theta. So as you can see, when you do 90 degree plus theta, every function is related back to its co-functions, and the signs has changed. Only cosine and secant remain positive in this case. So, well, how do we use this? Well, for example, okay, if I want to find out sine of 110 degrees, for example, I say, oh, okay, let's break it down. Sine of 110 is the same as 90 degrees plus 20 degrees, right? So as I can use the formula, sine of 90 plus 20 is equal to cosine of 20 degrees. Okay, what about cosine of 130 degrees? Well, I can break down 130 degrees to 90 degrees plus 40 degrees. So that will be an opposite of sine of 40 degrees. Okay, and then what about cotangent of 170 degrees? Well, 170 degrees is 90 degrees plus 80 degrees. Okay, so this will be the opposite of tangent 80 degrees. So this is another way to help us relay functions back to its relations functions in the first quadrant. The goal is just to allow us to be able to simplify. We have different rules and different connections, different relations. When we study them, we can relate different angles back to their first quadrant angles, or how they related back to first quadrant. And some of this will come very handy later on when we do identities and then other kind of problems. Alright, so let's look at another part of the take a look at what about 90 minus theta and see what happens. Now we take a look at functions of 90 degrees minus theta. Now we actually did this before. When you do 90 degrees minus theta, they are just basically what? Coterminal. They are actually just called complementary angles. Complementary angles. So complementary angles, so we can go ahead and quickly review that. We can use the right triangle to do that. So when we have the complementary angles, they are basically just equal to its cofunction with no sign of change. Okay, so all the 90 degrees minus theta is just equal to its cofunction angles with no change in sign. All right, so because they are complementary angles, they equal to their cofunction angles. So this is another easy way to understand their relationships. So all the 90 degrees minus theta, we're just going back to their cofunction. Okay, cosecant. Okay, the last one is cosecant. 90 degrees minus theta equal to secant. Alright, so you can write this down, and then this was another way to relate the angles between each other. Okay, this will help us allow, if you understand this and then you can familiarize yourself with this will help you a lot greatly in doing different calculations and examples and later on. Alright, now let's go ahead and move on to another set of functions that we use a little bit less, but then it's still very important. Okay. Alright, so now let's take a look at the functions of 270 degrees plus theta. So basically, this is the original theta, right? This is our original theta with r radius, with the x and y, the adjacent leg and opposite leg, x and y determining our function values. So let's take a look at 270 degrees plus theta. Alright, let's start with 270 degrees plus theta. Now, when you add 270 degrees plus theta, that means you add 90 degrees. Okay, hold on. You add 90 degrees 3 times, basically. So you go ahead and do 90, 180, and 270. So this will be the terminal side will form a 90 degrees with the angle theta down here in fourth quadrant. In this case, if I start with first quadrant, this will end up in fourth quadrant. Okay, so let's take a look at what's going to happen here. So the y value here is this, and the x is this distance. Okay, it's going to be a little bit overlapping with each other, but let me go ahead and label this. This is going to be r prime, and this is going to be y prime, and then there's a little x prime there. Now, as you can see, the y prime is going to be equal to negative x, but the x prime number is going to be equal to y. Okay, x prime is going to be equal to y. This angle theta will be right here. It's going to be right here as angle theta. They are the same angle because this is the complementary angle with theta. So this angle has to be equal to theta. This being a right angle. Okay. Alright, so this is true triangles again. They are called congruent, but then they are flipped. So we can go ahead and take a look at our sine functions. Alright, so 270 plus theta will be equal to y prime over r prime. Now y prime is negative x over r. R is the same, so it's negative cosine theta. Alright, so in third quadrant, in the fourth quadrant, when we add 270 degrees, the pattern changes a little bit. Let's go ahead and do everything and then figure out what's the pattern. Okay, so x prime over r prime. Sorry, I'm ready. X prime over r prime. So x prime is the same as y, r prime is r, so this will be sine of theta. Okay, so that's sine theta. That's right. And then tangent of 270 degrees plus theta will be equal to y prime over x prime. Now y prime is negative x, x prime is y, so it's negative cotangent of theta. Alright, tangent, and let's do cotangent first. Alright, now cotangent 270 degrees plus theta will be equal to y prime, x prime over y prime, but x prime is the same as y, but y prime is the same as negative x, so it's negative tangent is theta. So as you can see, we're still relating everything back to its cofunctions. Like cotangent is related, is going equivalent to tangent, and secant here I think it will relate to hold on, this is r prime over x prime, and here is going to be r over x prime is y, so you will be positive cosecant. So secant is related to cosecant, and here when we do the cosecant, 270 degrees plus theta is going to give us back secant, but it will be a negative secant. Okay, because y prime is equal to negative x, so it's negative secant theta. Again, the signs are a little bit different. So in fourth quadrant, when we add 270 degrees, this time we shift 3 quadrants, the sine and cosecant stays positive, everything else becomes negative. When we add the 90 degrees, when we shift 1 quadrant, if you go back here, when we shift 1 quadrant back in the beginning of this today's lesson, as you can see, cosine and the secant remains positive, everything else remains negative. Okay, and what about if we do 270 degrees minus theta? Alright, so let's go ahead and look at the functions of 270 degrees minus theta. Let's go ahead and see how we can do this. So this is theta, right? Now if I go ahead and draw an angle like this, that's 360 degrees minus theta. But 270 degrees is this. From here I have to draw another 90-degree angle. So it's going to be okay, let me see. So this is the 360 degrees minus theta, and then minus 90 degree again. That will give me an angle here. So this angle is going to be, let me try it again. So this is 360 minus theta, and then I'm going to draw a 90-degree angle. Yep, that looks a little better. I have a little reference there. So this is 90 degree. Alright, so I'm going to draw the y coordinate here, and so this angle is 270 degrees minus theta. From here to here is 270 degrees minus theta, and this is the y prime. I'm going to call this y prime again. So y prime, and then we're going to figure out what they equal to. This is x prime, and this is r prime. Okay, r prime is the same as r. Now I'm going to erase this guy here, so we're going to avoid any confusions. So this angle theta, as you can see, this angle is also theta because there's an angle theta here. There's a 90-degree angle here, so this angle must be equal to that angle. They are complementary angles of theta, and therefore this angle theta. So y prime is the same as negative x, and x prime is the same as negative y. So both of them are opposite of the values of our original angle triangle. So let's take a look at sine of 270 degrees minus theta will be equal to r prime over y prime. So r prime in this case is okay, I made a mistake here. It's y prime over r prime. So y prime is negative x over r. It will be negative cosine of theta. Okay, and let's do cosine of 270 degrees minus theta will be equal to x prime over r prime, which will be negative y over r, so it's negative sine. So in this case, both sine and cosine, they become negative. So that tells me tangent of 270 degrees minus theta will be negative, will be positive. Okay, so it will be negative x over negative y, so it will be positive cotangent. So the cofunction will change. Their cofunction doesn't really change. Their relationship is always related to the cofunction, but it's just sign has changed depending on the quadrant we're adding. So this becomes negative y over negative x, so it becomes positive tangent theta. And same thing for secant here. Secant is going to be related to secant, so it's r prime over x prime, so it's r over negative y, so it's negative cosecant. And then cosecant of 270 degrees minus theta will be equal to r prime. This x looks like lambda for a moment. So r prime over y prime, so it's r over negative x, so it will be negative secant of theta. Okay, so that's how we can relate the angles to their 270 degrees plus minus theta and 90 degrees plus theta. Now, to summarize this, we can say is that to find the functions of any angles between 90 and 360 degrees, of course except the quadrant angles, if we express the angle as 90 degrees plus theta or 270 degrees plus minus theta, then take the cofunction of the reference angle, because this is our reference angle here. So whatever that angle is, the cofunction, if we take the cofunction of the reference angle and give it the sign determined by the function of the given angle in the quadrant to which it belongs. So let's do just a few examples of this before we go. So let's try sine of 95 degrees. If we want to try sine of 95 degrees, we can express it as sine of 90 degrees plus 5 degrees, right? And then we remember sine of 90 degrees plus 5 degrees is going to be negative. Oh no, it's going to be positive cosine theta. In there, when you do 90 plus theta in the second quadrant, when we add 90 degrees, it will be positive cosine and secant. when we add 270 degrees, it will be positive sine and positive cosine. But when we subtract 270 degrees minus theta, it will be positive tangent and positive cotangent. Okay, so if I do cotangent of 250 degrees, now there are several ways I can do this. I can say this is 270 degrees minus 20 degrees. Is that true? Yep. Cotangent of 250 is 270 minus 220. So this will be a tangent of 20 degrees. Okay. What about cosecant of 300 degrees? Well, cosecant of 300 degrees is going to be equal to cosecant of 270 plus 30 degrees. Alright, so this will be a negative tangent, negative secant of 30 degrees, because this is 270 plus an angle. When you do 270 degrees plus an angle, they will become called a cofunction, but only sine and secant will become positive. Oh, that's right, it's sine. Yeah, I'm sorry, it's sine 30 degrees. Let me just go back here. Okay, look at this. Yep, cosecant is negative secant. Yeah, I was right. I'm sorry. It's negative secant. Sine and cosine are positive. Cosecant and sine are positive. Yep, sine and cosecant are positive. They're reciprocal. Sine is reciprocal positive. Okay, so let's try another one. Tangent of 315. Let's do 344 degrees. Okay, tangent 344 degrees. So that's equal to tangent of, you can do 270 degrees plus what? That will be for 74. Yep, 74. Okay, so 274. So that will be equal to negative cotangent of 74 degrees. Okay. So, as you can see, we can go ahead and go on and do a lot more examples. So next week we'll come back and do some examples and of all the things that we have learned so far and how to use them. But so far we have covered everything. Hopefully you can understand where everything comes from, and then this will be some guiding principles that will help us along to proceed to the next part of the lessons. Alright, please leave any questions and comments in the comment section below, and please remember to subscribe and like the video and share the video with other students and other friends that that also are struggling with trigonometry, and then hopefully everything will help you to understand the subject a little bit more. Alright, hopefully we'll see you in the next lesson.